In this video, I'm going to introduce an ingenious way to count the number of subsets of a finite set. All right, and so to begin, for this first example, we're going to start with a small set so you can kind of get your mind wrapped around what we're actually doing. And then in a later video, I'll extend to a larger set. And then in the last video, that will be what we're working towards. Okay. All right, so we're going to start with just this small set, the set containing only x and y, so two element set. All right, and it's really easy to see what the answer is. The number of subsets of a set with two elements is 4, right? There's the empty set, the set containing x, the set containing y, and the set containing x and y. But what I'm teaching you here is the method of encoding these with a unique binary number. Okay, so what we'll do is we'll start with subsets here. And I'm just going to write out all of the subsets of the set containing x and y. So the empty set, the set containing x, the set containing y, and the set containing xy. All right, so we might as well do this with a table. So I'm going to give myself a little more room here. So I'll make this into a table. See, we got the subsets. On the bottom here, we'll have the code. And in the middle, in this middle row, we're going to have some transitionary work that'll help you see how we get this code. Okay, we're going to use the number 1. The number 1 means the element is in, so let's just say is in, and we're going to use the number 0 for the code is not in. All right, now, so let's start with the empty set. Okay, so first question is x in the empty set? No, nothing's in the empty set, right? So we use 0 here. 0 meaning x is not in. Now ask yourself, is y in the empty set? Of course not. So we'll use 0 there. And so our final code will be 0, 0. So please try to understand how 0, 0 encodes the subset, the empty set, of the set containing x and y. And it's all embodied in what I have here, right? 0 in the first position means that x is not in the set. 0 in the second position means that y is not in the set. Okay, now let's do this again. Is x in the set containing x? Well, yes it is. Should put a 1 there. Is y in the set containing x? Well, no, it's not. So put a 0 there, and our final code is 1, 0. Now, let's see, is x in the set containing y? No, it's not, so we'll put a 0 there. Is y in the set containing y? Sure it is, so our code will be 0, 1. And lastly, is x in the set containing x and y? Yeah, it is. Is y in there? Is y in the set containing x and y? Yes, it is. So our code is 1, 1. Okay, now using these codes, I'll fill in my table here. Now, what you should notice is that that each of my codes is a unique, meaning different binary number. Y there. Okay. All right, and just to extend what we did last time, now the binary number, so I'll start with binary here, and I'll do base 10 over here. Zero, zero, written in binary. This means 0 times 2 to the 1 plus 0 times 2 to the 0, which is 0. Okay, 1, 0 is 1 times 2 to the 1 plus 0 times 2 to the 0, which you can see is 2. 0, 1 is 0 times 2 to the 1 plus 1 times 2 to the 0, which is 1. And 1, 1 is 1 times 2 to the 1 plus 1 times 2 to the 1, which is 2 plus, 2 to the 0, sorry, 0 there, which is 3. So the thing to notice here is that we have each of the subsets listed here. Each of those has a unique binary representation in this column, and each of those binary representations is really a number between 0 and 3 inclusive, an integer between 0 and 3 inclusive. And so now, how many subsets are there? Well, you already know the answer is 4. You can count them. But how do we know that without counting them? Well, see, there's 4 numbers here. There's 4 numbers there, 0, 1, 2, and 3. So in essence, we've counted without counting. And this is the beauty of bijections, functions that are both one-to-one and onto. Is there a nice way to count things?